Nice to meet you. I'm Shinya Nakashita from Hiroshima University. I'm very honored to join this conference. I have strongly relationship between Pugon National University. I have visited Pugon National University more than 10 times, and I have been conducting collaboration research with Professor Kim Kyung-hee in Pugon National University. Today, I'd like to introduce my research result in online. My topic is comparison of loss on ignition obtained from thermogravimetric analysis and ignition loss test.
First of all, I'd like to explain what is loss on ignition. Loss on ignition is an index of the amount of organic matter contained in sediment. In this presentation, I used loss on ignition as IL. IL is often used in our study area. The calculation of IL is as shown in this formula. Weight loss burned at x degree by sample weight dried at 100 degree. The x degree varies depending on the purpose of researcher. However, generally it burns at 600 to 850 degree and burning time is 4 hours. From this result, this is a note for researchers who handle IL. IL varies depending on burning temperature and burning time, so it is necessary to confirm the measurement method of IL. From previous study, we have investigated the burning temperature of substance or organic matter in sediment. This figure shows the classification of substance to loss weight by temperature. The important point is IL contains not only amount of organic matter, but also water including minerals, for example kaolin or momolisonite, and another compound, for example hydrate or hydroxyl group or inorganic carbon. So in addition, we can categorize organic matter by burning temperature. For example, labile organic matter such as fats and fatty oils or volatile organic compounds burn around 100 to 375 degrees. Humus and resistant organic matter such as humic acid, aromatic compounds burn around over 375 degrees. So in this study, I set maximum burning temperature is 850 degrees.
This slide shows how measure IL. There are two methods to measure IL. One is most popular method to measure IL. This is using electric muffle furnace. In this slide, I called it IL test. There are two features of this method. First, sample burn in air condition. Second, IL is usually only one value. However, new method has proposed in which the weight is measured after burning each temperature, for example, 200, 300, 400, 500, 600, and 850 degrees. Second is using thermogravimetric analysis. In this paper, I called it TGA. TGA is a method of simultaneously measuring the weight while applying heat to a sample. We can get the weight loss at each temperature. Improperly, TGA use inert gas, for example, nitrogen or helium. However, this study focused comparison with IL test, so we use air gas as an active gas. Moreover, the results depend on heating rate. However, the effect of heating rate on the result is not clear. IL test and TGA have the same principle of applying heat to measure sample weight. However, there are no studies comparing IL obtained from these two methods. So purpose of this study is IL obtained from IL test and TGA are same value. So I conducted two experiments. One is IL test in air condition with several temperature. The other is TGA in air condition with varying heating rate. In this study, I compared these results using same sample. This slide shows the method in this study. I use two types of sediment. Sample 1 is sediment with much organic matter. So total C is 7.71%. Sample 2 is sediment with little organic matter. Total C is 3.19%. This sample was sieved 75 micrometer filter. In IL test, sample was burned 200, 300, 400, 500, 600, and 850 degrees. And the burning time 4 hours each step. In TGA, sample was burned continuously from 100 to 850 degrees. Heating rate of 5 or 10 is generally used. However, in this study, heating rate of 0.2, 1, 2 were also used. Okay, let's move to result. This figure shows that IL result. In this paper, I used only this figure. So first, I explain the these figures. So x-axis means burning temperature, and y-axis means IL. When the temperature of the sample rise, water and organic matter volatilize, so the IL increase. Muffle is in the legend represent to the result of IL test. Another result shows the TGA with each heating rate. Left figure means the sediment with much organic matter. Right figure shows the sediment with little organic matter. First, I discuss the TGA result with different heating rate. So you can see the IL obtained TGA change with the heating rate. For example, the IL at 300 degrees increase as the heating rate decrease. Before the experiment, it was expected that the result of IL would be the same if the heating rate was decreased. However, the results were inconsistent, even for sample with little amount of organic matter, like this. So, it is understood that this tendency don't depend on the amount of organic matter. So, next I discuss the comparison with IL test and TGA. So next, I discuss the comparison with IL test and TGA. So you can see that both results roughly match. At the heating rate is 0.2 degrees per minute. However, it takes 5 days to increase the temperature from 100 to 850 degrees with a heating rate of 0.2 degree per minute. So therefore, this heating rate is not useful for analyzing many samples. On the other hand, the IL of the both methods at 850 degrees were matched regardless of the heating rate. From this result, it was shown that the 850 degree is useful for comparing the result of both IL. This is the last slide. This is the conclusion. One is IL obtained TGA change with the heating rate, and the tendency does not depend on the amount of organic matter. Second is IL obtained IL test and TGA roughly match at heating rate is 0.2 degree per minute. Last is the IL of both methods at 850 degree were matched regardless of the heating rate. Okay, finish my presentation. Thank you for your attention. If you want to contact me, please send email following mail address.